Okay. So hi, everybody. I thought that because we're in our project phase now, we've talked a little bit about Git. I would talk a bit more about Git today and share a few new commands that some of you may have heard of, or you may not have. But hopefully at least one of them will help you as we move forward with projects. So just as a refresher, what's Git? It's version control software used for managing changes for source code in programs and projects. As you know, Git is great. It's distributed, so users can copy parts of a project or a whole project onto their local computers, work locally, work offline. It's fast, it's more efficient. It's also safe because you have many backups. Key feature of Git is that you can have multiple independent branches, allowing you to do nonlinear development, so you and I can work on two different features at the same time. We can easily switch between contexts, and also you can experiment, and you can always throw away your code if it doesn't work. Git has 3 states. I know you've all probably seen this, we've used it, but this is important for the commands I'm going to talk about. So just as a refresher, the head state is what points to the last commit on the branch that you're on. The index, also known as the staging area, is where you put your proposed next commit. And then the working directory is like your sandbox. That's where the actual files are, and when you make changes, that's where you're doing that. So here are some basic commands. Again, you should all hopefully know these. But I'm going to talk about 4 that hopefully at least one of them is new to each of you. So the first one I'm going to talk about is git stash. So I really think this scenario has come up for all of us so far. You're working on a branch. You're not done your work yet. You need to switch to either help somebody, or in a real world scenario, you need to work on a fix, a hot fix or something, but you can't switch branches until you do something with those changes. So this is where git stash comes in handy. Just by running this git stash command, it'll move the changes that you have in your working directory, whether they're staged or not, onto a stack of unfinished changes. That leaves you with a clean working directory, and you can easily switch contexts. At any point, you can do git stash list. Is this going to update? Maybe? No. Hold on. There we go. Okay, so you can run git stash list and see all the changes that are on your stack. And then when you're ready, you can run either git stash apply or git stash pop. Git stash apply will take the changes that you put aside, reapply them, but it will stay on the stack. Git stash pop will obviously remove it from your stack. One key thing to note is that you don't actually need to have a clear working directory when you want to reapply. Git will tell you if there are conflicts, like usual, and ask you to resolve them before it continues. Once you're ready, you can also clear and drop things from the stack. Clear removes all of them, drop allows you to pick one to remove by itself. And you can also do git stash branch, which will create a new branch and drop what you want on it. The next one I want to talk about, once this updates, maybe, is git reset. Don't know why that's out of sync. Okay, so say you didn't stash your changes and you went ahead and you committed them, but then you realized that was a big mistake. This is where you can use git reset. It allows you to erase your mistakes and basically create a replacement history and undo things that you haven't, as long as you haven't shared it with anybody else. But before I go there, I just want to walk through again what happens when we do make changes. So say you made a change in your working directory. When you do git add, it adds a copy of it in your index. And then when you do git commit, Git creates a commit object that points to this snapshot, the snapshot of this work, and then points head to that object. Git reset allows us to walk back through those steps one at a time. So when you first run git reset, the first thing it does is updates head to point to the previous commit or the previous branch. You can stop here by using the soft command. So at any point you're here, you can change your commit and recommit if you want. If you don't tell it to stop, the next thing git reset will do is update your index. So what it'll do is take whatever context contents that your head now points to and copies it over to your staging area or your index. At this point, git reset will stop. So you can, again, replay your add and your commit if you want from your working directory. Thirdly, if you really want to, you can run a git reset hard. This will actually update your working directory. So it's going to roll back completely and actually remove and delete any of the files or changes you had in your working directory. It's kind of dangerous. It's one of the few times Git will actually destroy data because it can't be undone. So like I said, at any point, if you didn't do this, you could always just add and commit again. But once you roll back this, you're kind of lost. You've lost your changes. Alternatively, you can use reverting. Reverting undoes a commit by creating a new commit. So instead of rolling backwards, it just undoes your changes and records it as a new commit. So you can actually see that that happened. Contrast this with the git reset, which actually does alter the existing commit history. So for this reason, they usually suggest git revert be done on public branches, and you only use git reset when it's something private on your own computer. The next one I want to talk about, if this transitions, is git rebase. But to explain how this works, I want to go over what git merge does. Because again, it's something we're using a lot, but I don't know if everyone's paying attention to what's happening. When you do a git merge, right now what git does is it takes, it looks to see where the two branches diverged, and then tries to merge them together, and it sort of interacts your merge and your commit histories. Sorry, intertwines so that they come in according to the order that they were made, and then makes a new commit at the end. That commit tracks your merge. Of course, if there are conflicts, you're asked to resolve them. Git rebase, on the other hand, takes what you want to, the feature that you want to add, and adds it onto the end and makes new commits, as if you built this feature after you did everything else. So instead of intertwining the histories and the commits, it adds it on the end. Yeah. So what's good about git rebase and what's not? So obviously, if I go back, it looks like it's a cleaner history. It's easier to read, especially if you're doing, this is a feature. You can see when things happened. You can follow the flow. You can see when bugs are fixed. But it is also really confusing, especially when you're collaborating. It's hard for you to see when things happened, why, and it can also cause issues when you do this on something that's shared, because when I do a rebase on my version of the files, when someone else merges, Git's going to think that our branches are different, and it may remerge everything again. So it's a bit dangerous. There's also an option to use this I command, it's interactive, and it allows you to edit your commits before it actually moves everything over, which is kind of neat. Some bonus commands and scripts for you to check out. Git cherry pick allows you to take a commit from somewhere else and play it back wherever you are right now. Git amend allows you to amend a previous commit with currently staged changes, or you can also change the commit message if you want. Git blame, if a bug was introduced, you can use it to see, you can specify specific lines of code, and it will tell you when they were edited last and by whom. Yeah. Just one more tip. I actually did this yesterday, and Phil has been using it too. If you install C Shell, it comes with some pre-installed Git aliases, which are really nice. So instead of writing out this massive long line when you're trying to push a branch in, you can just do GGP, and it does that for you. And just some more resources for you here. Any questions?